Hello, and welcome to the RICS World Built Environment Forum COP26 mini webinar series. I would like to take the opportunity to thank ASITE, our lead tech partner. None of this would be possible without their support, so we're very appreciative of all of their input. My name is James Fisk. I'm Director of BCIS, the Building Cost Information Service of the RICS. Today we're going to be discussing lowering embodied carbon, a whole life approach to decarbonisation. The built environment is responsible for around 40% of global carbon emissions. So we need to act now in order to combat the impact of climate change. So this is a very topical, a very important topic for us to cover. Over the next hour, we're going to struggle to squeeze in all of the aspects of it. It is quite complex in some aspects. So I'm incredibly pleased to be joined today by three experts in the topic. Dr. Zayed, who's Senior Lecturer from Northumbria University. If you can come on your cam and just say hello, Dr. Zayed, that would be fantastic.
Good morning, everyone.
Great. Please introduce yourself, Dr. Zayed.
My background is in building engineering, and I carry out a variety of teaching and research. And I hope today to give you very much a practical example of how embodied carbon can be calculated and can be captured as part of the whole life cycle, rather than just a purely academic view.
That's brilliant. Thank you so much for joining us today. Also very pleased to introduce Martha Dillon, Sustainability Consultant at Bureau Happold. Martha, welcome.
Thank you. Hi, I'm Martha Dillon. I'm an engineer at Bureau Happold. I'm originally a civil engineer, but I now focus on net zero strategies and carbon accounting. And I'm really interested in talking about different approaches to reducing embodied carbon through reimagining the spaces we live in.
Thank you, Martha, and a very warm welcome to you. And last but by no means least, Neil Pennell, Head of Design and Innovation at Property Solutions at Landsec. Neil, welcome. Can you hear us?
Yeah, hi everyone. My name's Neil Pennell, as James just said, Head of Design and Innovation Property Solutions at Landsec. We're one of the leading real estate investment trusts in the UK, and we own property across the UK. We develop new buildings, we refurbish and reposition existing buildings, which obviously involves looking at the use of carbon, both in their operation and construction. So I'm here to give a client's perspective, but also to share with you some of the innovation work that I've been doing to look at driving down embodied carbon in buildings.
Thank you, Neil, and warm welcome to you. Thank you to all the attendees that have joined today. We've got registrations from over 20 countries, and of course we're very keen to get you involved in this webinar as much as possible. So I ask all of the attendees if you'd be so kind as to submit any questions to our panel. It really sort of helps bring the conversation to life. If you're new to the webinars, we should see that you can submit your questions at any time using the question box on your screen. We will pick up obviously as many as we can as we go through the sort of questions and go through the session today. So any technical questions, obviously, yeah, just please put them in. We'll try and help you as much as we can. Okay, so yeah, it's a big topic, lots to sort of go through today. I think what would be helpful first of all is really if we could start to put some life on the definition of operational and embodied carbon and life cycle analysis of the building. They're big technical terms. The construction industry is at times quite confusing. I wonder if Neil, if you'd be so kind as to give us a brief sort of definition of some of the things that we're going to be sort of chatting through today.
Okay, yes, I'm happy to do that. So if we start with operational carbon, those are carbon emissions associated with the energy consumption while the building's in occupation. It includes Regulated loads, so it's sort of divided into two parts. Regulated loads, which are those that building regulations recognise when you're looking at the performance of buildings, but also unregulated loads such as from IT equipment, cooking, refrigerators, etc. In terms of embodied carbon, those are the carbon emissions associated with the materials and construction processes over the whole life cycle of the building. It includes any carbon emissions created during the manufacture of materials, extraction, transport to the factory and manufacturing of those materials, transport of the materials to site, and construction practices used actually to create the building, and to continue to invest in it over its life where it involves modifications to that building. And in terms of a life cycle analysis, that is really looking at the holistic view of the whole life of the building. It's a methodology for assessing the environmental impacts associated with all stages of a building's life. It's sometimes described as a cradle to grave type analysis, or as we're now looking more at a circular economy, perhaps cradle to cradle, where those materials can be used again into the future. And it effectively includes both operational and embodied carbon, so assessing the whole impact of the building through its life.
That's
so
brilliant.
hopefully that's a good starter for 10.
That's absolutely brilliant. Thank you. Yeah, it's a very complex area, so I'm sure that would help all of the attendees today. So I mentioned in the introduction that obviously the built environment is responsible for around sort of 40% of global emissions. I suppose the first question for us as a panel to start to talk through is how important is lowering embodied carbon, bearing in mind that Neil's obviously talked about the differences there between embodied and sort of operational. How important is lowering embodied carbon to meeting that net zero sort of obligation? Martha, I wonder if I can come to you first of all with your thoughts on that one, please.
Yeah, I mean, lowering embodied carbon is absolutely critical to meeting net zero. So at the moment, typically operational carbon, as Neil explained, is the only thing we really report on or account for, even when LCAs are done for the whole building. But actually, the embodied element of carbon is enormous. So in the UK, where I think we're all based, it's about a third at the moment of emissions from the built environment. And as our power supplies decarbonise, that operational energy will shrink, hopefully, but the embodied energy could end up being a really huge proportion of remaining emissions. So it's really critical. We think about it, we worked in a joined up sector, so we should be thinking about all the elements of carbon that arise from our projects and activities. I think the second reason that sometimes gets lost in conversations about net zero is that there's also a really huge environmental damage and social impact of some of the materials, the high carbon materials we're using. So we sort of talk about waste and pollution as kind of throwaways or co-benefits, but there's a very real impact of the materials we use today, and changes for net zero is also a real opportunity to clean up the sector more broadly. And I think that we are starting to talk about it more. I know a lot of the COP26 events like this event are talking about embodied carbon more, but realistically to fully decarbonise and remove embodied carbon from our sector, we're not seeing the pace of change we need in the coming decades to eliminate embodied carbon. And I'm really excited to talk today a bit more about what some of those strategies might look like.
That's great. It's a fantastic challenge for us, isn't it? So yeah, there'll be lots to talk through today. Dr. Zayed, if I could come to you and just get your thoughts on how important lowering embodied carbon is to us.
It's extremely important. I've described it, I think, in a recent publication as the dark side of the construction industry. It's something that we can't really see, we can't visualize, and therefore its impact is enormous. If we take, for example, the aviation industry, it contributes 2 to 3% of global emissions, and we all talk about reducing our kind of long distance, long haul flights, but in a way, embodied carbon, specifically steel production, concrete production, and that contributes to about 8 to 10% of global emissions. So that's a huge, enormous figure, and we need to do a lot to try and address it in the long term. And as Martha mentioned, we are sort of, as part of the COP26 initiatives, we need to be looking at not just net zero operational, but also net zero kind of total carbon reduction. And we can only do that by almost starting immediately and addressing the having a specific strategy where we start estimating it, then we try and maybe use substitutes, and it's a gradual process that we need to engage the construction industry on, and that's part of the overall climate engagement and greater awareness, I assume.
It's an absolute staggering number that embodied carbon is responsible for, really, isn't it? It's and so easily and commonly overlooked. It is quite scary. Thank you, Neil. Can I come to you and just get your thoughts on that as well, please?
Yeah, I think obviously operational carbon, as we move to a decarbonised grid, as Martha said, I think we're going to see that reduce in its importance. And the whole focus in terms of the carbon invested in the built environment is going to be that used to construct it in the first place. So hence the real importance of lowering embodied carbon to meet the overall net zero obligations. And if we look at the more informed definitions of net zero carbon, when you look at them in a built environment context, they include both the operational carbon and the embodied carbon. So UK Green Building Council is a good example of that. And it's the one that we've adopted as a target for our buildings.
Okay, that's excellent. So yeah, I think we're all in agreement. It's a big thing. We need to be looking at it. I suppose the real challenge for us is how do we measure this? How can we accurately measure it? How can we consistently measure it? I think is probably an important part of that sort of question as well. Dr. Zaid, if I can come to you first, and just perhaps you could start by just explaining how embodied carbon is measured and how we need to perhaps sort of start to improve on some of the accuracy and sort of consistency of that measurement. That would be great.
Embodied carbon can be measured in a variety of different ways, and I started doing some research on this about 10 years ago when I was in my role as a BREEAM assessor and a Code for Sustainable Homes assessor, if anybody remembers that kind of government initiative of zero carbon housing. And initially I started doing it manually. I was getting a bill of quantities of a house or a building, and I was trying to find the appropriate numbers that represent the impact associated with the various materials. So you can take a kind of a typical project and you identify various elements of it, and you can get an estimation of what these different elements contribute. There are, without sort of getting too technical about this, there's you need to sort of have boundaries for what you can measure. So there are some international standards such as the ISO sort of 1400 series, and there is also a standard which is EN 15978, which actually looks at the boundary of the materials, and I think that's been widely adopted by a lot of organizations. So this actually covers the raw material production, the consumption, the kind of the in use, and also the decommissioning phase. So there's also, as opposed to doing it manually or doing it through an Excel spreadsheet, you can use off-the-shelf tools which exist. Some of these you have to subscribe to. There are licensed ones, and others are not. And I've seen a variety of architectural practices, for example, develop. An example is Field & Clegg Bradley have their own sort of in-house Excel spreadsheet. There are international sort of tools such as One Click LCA, Tally, Hoskins Brown have their own. So there's a variety of different ones. There's also to sort of bring it into the world of digitalization. A tool that was released last year is the EC3 tool, which was largely based in North America. And this ties in for anybody in the audience who uses digitalization and BIM 360. It plugs into that, so it simplifies the process. I have to just add that the sort of take it a step before that, and at the heart of all these measurement tools, there's this concept called the Environmental Product Declaration, which is very important, which is almost an assessment, an externally verified, an independent assessment of the impact of the material on the life cycle of the building. So there are a variety of different ways of measuring it, and as I mentioned, from manual to kind of fully automated. It depends on the size of the project, the requirements of the client, and also the kind of skill set within the design team, and also the kind of engineering team. So I think that's the sort of initial way of how you can measure carbon.
Great. No, that's excellent. So there's ways to measure it. I suppose my concern is the consistency around that measurement at the moment, and in particular, obviously, things like the data that people are using as part of those assessments. Martha, do you have any sort of thoughts on that sort of consistency challenge that we have ahead of us?
Yeah, I'm an LCA assessor, and certainly, the tools we use are great, but there are there's huge room for improvement. The availability of EPDs is a real challenge. But I think what I would say is that even if we are counting embodied carbon emissions accurately, and these tools improve, we could and can get very bogged down in the numbers and trying to sort of pin individual emissions onto different groups. So, for example, you often see companies not wanting to report or take responsibility for operational carbon because it's someone else living in their building, but those design companies, have responsibility for the heat source and the fabric efficiency that is really fundamental to the operational emissions that then result. So we are starting to measure it accurately, and that consistency is something that will build as we get better at it and these tools develop. But I think it's really essential that we stay focused on the goal, which is to completely remove emissions, and to do that collectively and take responsibility across the supply chain to do that. So I think we should have our sights set on adopting strategies that broadly work in terms of reducing embodied emissions, and not take too long trying to find the perfect accounting tool, and leave those strategies too late.
I guess part of that is being able to share experiences and learn from what's worked, what didn't work in sort of other projects. So a way of sort of sharing that experience sounds like it's a sensible sort of step for us. Neil, can I sort of come to you with the same sort of point of this sort of consistency sort of measurement? What should we be doing here? Are we on the right road? Will we get there quick enough with the current sort of activities and tools and things that we have at our disposal?
Well, it's an interesting question. I mean, I've been focusing on embodied carbon for about 10 years now. We've been trying to assess it on buildings using different assessors and different tools over that period of time. Databases that started off pretty much based on very limited information that have become better over time. I think the problem for the embodied carbon piece is that sort of accuracy and comparability between assessments done by different assessors and the methodologies, and the accuracy of the databases that are being used as a starting point. But ultimately, if you've done an assessment on your building, whatever method you've used, whatever data you've used, you've got a starting point to then compare against to try and drive down the actual emissions of the building that you create, or the work that you do in that building, if it's refurbishment or repair or maintenance work on the building, because all of those involve embodied carbon investments over time. So it's easy for the operational energy side. Ultimately, you can meter the energy and resources that are being used in the building that are measurable: water, gas, electricity use. So you have an accurate idea of what the operational energy is, whereas the embodied carbon at this moment in time is an assessment that's getting gradually more accurate over time as the information gets better. And I think as we drive forward and it becomes the main focus of carbon reduction in the longer term, then we're going to have to rely on the supply chain that's providing the materials to actually start measuring the carbon that's involved in the products that they create, so that we've got real accurate data to go forward. And then that might make it easier for people to regulate in the area. At the moment, it's difficult when two different assessments of the same building could come up with different answers. But the important thing is that whatever process you use, you can do that relative assessment, and you can keep driving down the embodied carbon that you're using in the construction processes that you're engaged in.
So it may be wrong, but it's, if you're consistently wrong, you can at least drive in the right direction. Neil, is that what we're saying there?
Yeah, absolutely. And you know, over the decade that we've been assessing the embodied carbon in our buildings, those assessment approaches have become more normalised. People have collaborated. The databases that are available are much better than they were 10 years ago. And I think a lot of manufacturers are realizing that, clients are asking questions of their designers, and they're asking questions of the supply chain. Because when you're doing that relative assessment, if you start off with the generic figures for the components you're using, you really want to find out of the suppliers who can do the best job, if you like, against that particular material or component. So it's in their interest to show that they can compete in terms of lowering their embodied carbon levels in their products, as well as competing commercially to get the projects with their clients.
Yeah, that's great. Thank you. And just sort of on the similar sort of topic, do we think that things like the supply chains are equipped enough to be able to do it? Do you think we have the right understanding of how to do that sort of calculation, Neil, within the supply chain? We're going to need more. We're going to need the whole industry getting behind it. Every layer of the supply chain will need to sort of give more data and more information. Do we think that the knowledge is high enough yet within the supply chain, or as an industry, do you think we need to be doing more there as well?
Well, I think it's got to improve from where it is now, but there is a degree of understanding. Some companies are ahead of others in terms of the information that they can provide. But manufacturers generally have a pretty good handle on their own supply chains, where their materials come from, the energy that they use in manufacturing processes. So they have a pretty good idea of what the embodied carbon is in their particular products. And working with their own supply chains, to get even greater level of granularity and detail is going to drive the accuracy going forward. So I think it is an area that is improved significantly over the last decade, and will be probably unrecognisable in 10 years' time. And it will be familiar to everyone, and everyone will understand the reasons for it. And we will see significant steps happening, I think, over the next few generations of construction work buildings that are produced in the next 10 years.
That's great, thank you. We've had a question posted by an attendee, more of a statement than a question, that ICMS, the International Construction Measurement Standard, is working towards ICMS 3, which is covering measurement and reporting of embodied carbon. So for the first time ever, sort of linking sort of costs and carbon together, I think is what the post is saying. Can this be a better way of measuring in one standard internationally? Is the question that's sort of been posted there. Are you familiar with ICMS 3 and the activities that are being done there? I'll ask for a generic question. Are we as a panel familiar with the activities that ICMS 3 is trying to cover? Not at the moment. Okay, so I can
not specifically that standard, but I mean, there's been a number of attempts to try and get people to adopt similar methodologies and different approaches. Firstly, within the UK marketplace, but certainly international standards are great, and will drive consistency across the whole global economies, which is great, because we get materials from all over the world in the process of creating buildings. So these are important steps, but getting international buy-in takes time, and to get standards agreed and ISO standards that everybody can adopt take time. We haven't got time to wait for all those standards to really get to a point that everybody accepts them, but if progress has been made, then that's great.
Yeah. I think in the if I can just add, actually, in the UK, we have the ICE database, which is probably a free downloadable database, which a lot of us actually use, and it's been applied also internationally. I've done it in work in kind of in sort of an Asian countries context, so developing countries, where we've applied that where a local database doesn't exist. But I just want to emphasize something which is important. You mentioned what the which came in the question is there's two distinct things between reporting and actually acting upon what your findings are. And until we get to that stage, you can report your embodied carbon as a percentage of your overall whole carbon emissions, but if you don't do something about it, if you don't go back and redesign the scheme, and if you don't actually look at the infrastructure and how you can substitute it for lower carbon materials, well, it doesn't actually, in the long term, that's not really what we. So we need to have a kind of a 10-year plan of saying, right, we're all going to start assessing our carbon for projects, and then we're going to do something about it, because that requires a specific set of skills to do that. And I think this is really, really critical. And sort of two examples I can give recently is I think Microsoft Office in North America, the Redmond campus, used a kind of the EC3 database to calculate their carbon emissions, and we need such big exemplar projects. And also the British Columbia version, I was doing a sabbatical with Ride Architecture there 2 or 3 years ago, and there it was compulsory to carry out an embodied carbon assessment as part of your submitting your planning application. And because they've done that now, they're moving on to kind of substitutions and kind of looking at alternative materials, which is critical. So you need this kind of phase of actually doing the assessment and then acting upon them and finding alternatives.
Yeah, that's great. Excellent. Okay, I think we could probably spend the full hour just on this question, but I'm going to move us on to the next one, if that's okay. It's the big question. You know, we're big consumers of cement and concrete and steel, which we know are highly carbon intensive. Are carbon neutral materials available? Dr. Zayed, I'll come to you first, if I may, with that question. In terms of your experience, of you and sort of substitutions and getting lower carbon emission values for those sorts of materials, is it possible?
It is possible to find alternatives. However, and through environmental product declarations that have a lower CO2 per square meter, it's also possible to look at. You can't look at that independently. You need to look at it as part of re-engineering, redesigning. So you're using less of the concrete, and that's really, really critical. There are substitutes for concrete, which rely on. So the main contributor in terms of concrete is the cement, Portland cement, which is a huge consumer of energy, and you can use alternatives which use pulverized ash, or an alternative which is from the iron ore processing, GGBS. And I do know a manufacturer that I used in my own domestic extension. I was very much keen on reducing the embodied carbon of a domestic 30 square meter extension to my house, and I was one of the sort of first people to use just like normal concrete. It's produced by Cemex, and it's called Virtuo, and that actually reduces the amount of concrete by the cement used by 30-40%. Now you can go up to 50%, 60%, and so on, but that was what was available at the time. You can, and just to give you an example of how I was the first person in the northeast of England to use this. So that we need to kind of open up the demand. If you're on a busy construction site and you need to order your concrete, this needs sort of some forward thinking of seeing where can I get this concrete from. You can use substitutes to kind of normal insulation materials, which are non-oil based. So you get wood fiber insulation, for example. And the ultimate example is actually using more wood, timber frame construction, which is actually something that we should do more of. But it's actually not just about using the same volumes, but about doing the assessment, re-engineering, and redesigning what we're doing. So there are a lot of alternatives. You can get them from main kind of builders merchants, but you might have to order them in advance. And I think the sector isn't there yet in terms of development. So there's also, in terms of looking at the overall carbon footprint, we need to consider the impact of the components we use. So a recent study that looked at the embodied carbon in heat pumps. So that's kind of a, there are guidance for that as well, and I do know some firms are trying to reduce that. But yeah, there are alternatives, and we should ideally get to a level where the EPDs that have the highest impact are eliminated from the supply chain, therefore increasing the market share of the lower impact products.
I suppose part of the challenge there is also being able to find those alternates. As a construction professional, where do I go? Where do I look for alternates? And I guess that's something that as an industry we need to get a little bit better. I think it goes back to that original point of sharing and learning from other projects. Martha, I'll come to you if I may. You must be regularly changing materials on to try and reduce the impacts. Your thoughts on this, please?
Yeah, I mean, recently we've been working on a study with the UK GBC where we take a sort of existing project and take it through various design permutations to reduce operational emissions, reduce embodied emissions. And at the moment, it's really challenging to do. If you're just doing like-for-like material substitutions, which seems to constantly be the default, the products aren't there. We don't have a great supply of low carbon materials. Mass market zero carbon concrete doesn't exist, certainly not without offsetting and approaches like that. So I think I would build on what Dr. Zaid was talking about in terms of re-engineering at a more fundamental level. We have vacancy rates across the world, structurally sound buildings that are not used completely, all day, but also at all in many cases. How do we optimize the use of the building stock we already have? How do we maintain the buildings we already have so they last longer and we don't need to demolish them? I think that's really the missing link. As an industry, we're very quick to wait for material substitutions and these products that don't exist yet, when actually there's a massive opportunity to be reimagining how we use the spaces, rethink the spaces that we already have, and I think that gets lost in the conversation very quickly.
Yeah, that's a really good point. Excellent. Neil, if I can move on to you as well in terms of your experience in this sort of substitutions and reducing our emissions.
Yeah, well, I think I'm working on a project at the moment, which is our innovation project known as the Forge, and it's a 2-office building development in Southwark. We've approached the design stage of the building using a design for manufacturing assembly approach and a platform of thinking about a methodology that we can reuse time and time again in buildings in the future. So it's about designing something really well and then using it many times going forward as the idea of a platform. But in doing so, and the approach that we took, we were able to reduce the steel in the building by over 40%. We reduced the concrete. We also used a high GGBS mixed concrete at 40%. And combined together, we did an initial assessment of the building's embodied carbon, and we were able to reduce that by, I think currently we're about 25% below the starting point. And over 19.4% of that was delivered by just those interventions with the steel and concrete. So designing it with the minimum of materials and then looking to reduce the embodied carbon of those materials to create a step change reduction. So that's sort of where we're at in terms of innovation now. But I think there is a lot of positive things on the horizon. The steel industry's got a Steel Zero initiative where they're looking to try and drive the production of steel to arc furnaces that actually run from renewable energy. So you'll be able to have a low embodied energy product, if you like, in the future. There's a tremendous amount of research in the world of concrete. And one really, the cement-free concretes, the problem with those is the time it takes for them to reach the strength. So you have to change your approach to design or use that concrete in a location where having to get the strength quickly is not an important part of the build cycle. But really interestingly, there is, I think, one or two products now on the North American market, and I think there's a lot of research going on in Cambridge to look how that you could introduce CO2 actually into the concrete process of creating concrete, and effectively that then mineralizes the CO2 and locks it up forever within the concrete and actually becomes a concrete sink. So what is it like, if you like, a major challenge for us at the moment could become an actual part of a solution going forward. So there's some really positive things on the horizon, but in the meantime, we need to take all the practical steps to design with the minimum amount of materials needed to do the job, and then minimize the carbon footprint with the supply of the materials you then choose to deliver that particular piece of construction. And obviously, as Martha has said, where we've got buildings that are already existing, if they can be repurposed and refurbished and their life extended, then that's something we should definitely be doing as well. So all of those things, you know, when we design new build, because we're making that investment in carbon, we need to be designing for longevity. We need to be designing for future deconstruction and reuse of those materials. And as I say, with the methodology, which is sort of borrowed from the manufacturing industry, that design for manufacturing assembly, that really drives thinking in terms of reducing waste, minimizing material use, and coming up with solutions that you can reapply time and time again and improve them over time. And then they become a real platform, or PDFMA as the terminology is called.
That's brilliant, absolutely fantastic. Lots to learn there. That's great. Conscious of time, so I'm going to move us on to the next question. And as we ask ourselves this question, panel, we've also had another question in from one of the attendees, just asking, excuse me, what tools specifically, we've mentioned a few, do the panel use to measure embodied carbon? If each of you can answer this, is the question that we've been posed there. So we've talked a little bit about reductions in embodied carbon being incorporated into the design stage. So what the way that I'm going to ask this question to you is that obviously there could be trade-offs in terms of additional costs. We know as an industry at the moment we are struggling to get certain materials and getting them into place for our standard construction sort of activities. Is there a risk that, you know, the additional premiums we're paying at the moment for materials is almost losing our ability to do those sort of trade-offs in the design process? Again, Neil, I'll come to you with that if I may, and also ask you that question in terms of what tools you specifically use that we've been posed as well, please.
Sorry, I'm on mute. The assessments that we have done are done by specialist consultants, so I don't know personally what specific tools they're using, but we employ consultants that work with the sort of software solutions that I think were mentioned earlier by Dr. Zaid and Martha, and I'm sure Martha as a practitioner will be able to give you a better answer than I can. We demand that the process is done, and then we work closely with our design teams to ensure that we do that other thing that Dr. Zaid said, which is to act on the information that it gives us to drive improvements in the embodied carbon in the materials that we're using, and to also challenge the designers to design less wasteful processes, more accurate construction design solutions, where we know then we'll be able to move much more of the materials that are used on site to be pre-manufactured in locations where, again, you can control the energy, you can control the waste, and you can produce much more effective and efficient methodologies. So I think I would swiftly pass that one over to my esteemed colleagues on the panel, who actually do these calculations for me. Thanks.
Neil, before we move on, if I can just ask you a question around the trade-offs. So there are alternates in terms of lower embodied carbon materials. How do you trade those things off if they cost more money? How are you confident that perhaps those lower embodied carbon materials will last as long? Are they durable as other options? How do you sort of consider all of that during the design process?
Well, I think if you take the concrete element, I think I touched on the fact that you've obviously, with structural elements, you have to meet the structural performance requirements of the buildings. And these are sort of been codified for a long time. There are demands on designers to ensure that buildings are safe and secure, and therefore it's important that structural components perform as they're expected to. But the knowledge around the performance of materials as you put replacements in, so for example in concrete, putting the blast furnace slag into the concrete and reducing the amount of cement is a standard practice in terms of reducing the embodied carbon of cement. And on the project that I mentioned, we've been able to adopt a 40% GGBS mix in the concrete that we're using. And part of that's been possible because the design of the way the building structure has been predicated allows us to move the construction cycle quickly without relying on the strength of the concrete. Because we're taking loads back into the primary steel structure rather than relying on transferring them through the concrete at an early stage. So it's a holistic thing. You've got to look at the design, and that's why it's so important that the designers need to be thinking how the building is being built when they're doing their design, which the sort of design for manufacturing assembly approach forces you to do that. And if you understand where the constraints are, you can design around those constraints with your solution so that you're able to use those lower embodied carbon solutions. And then it's about, as I said earlier, challenging the supply chain. So when you start off with a benchmark figure for steel that will come from the benchmarking data that Dr. Zaid mentioned earlier, you're then looking for suppliers that can give you evidence that their steel is a lower carbon than what the typical average would be. And that could be because the supply point is much closer to your site, there's less transport energy. It could be the methodology used to smelt the steel. It could be the level of recycled steel within the component. And when you do your assessments, you should look across all of those things. And it doesn't necessarily cost more money. Quite often you'll find that cost follows carbon. The more energy intensive a product or material is, it's more likely to be more expensive. So it doesn't have to be a trade-off financially. It's about interrogation, it's about competence, it's about pulling together the design with the construction and with the supply chain that supports it. And taking us away from perhaps the siloed thinking and siloed processes that characterize the construction industry at the moment. It means a lot of new thinking, new approaches. We've got lots of great tools now, digital tools that we can track processes, that we can capture good practice much more easily and codify it into repeatable components that can be used in buildings, and then work with the supply chain to improve the embodied carbon level in those components. And I think, as Dr. Zaid said, if the people at the top end of the figures start to find it difficult to sell their products, they're quickly going to be redesigned and taken off the market, or those companies themselves will not have a product to sell. So it will be a self-fulfilling cycle, I think, once we get the momentum behind that thinking. And I think a lot of leading developers in the UK are looking at embodied carbon, do embodied carbon assessments, and challenge their design teams and their constructors to improve the levels going forward. What we have to do is to take that, if you like, from the leading elements within the industry and spread it right the way through to the builder that was coming to do Dr. Zaid's patio or whatever it was you were building with your concrete that you had to procure for them yourself to make sure they use the right stuff.
Single story extension.
Well, there you go.
Thank you, Neil. Martha, can I come over to you, please, for your thoughts?
Yeah, I think again, before you get to choosing a tool, the question to be asking is, is this building necessary? Are there different ways to meet the demand for the new building? Is there building stock that could be adapted or refurbished or sort of rethought? every ton of concrete that we use today is emissions in the atmosphere. We're in a climate emergency that, you know, this we can't keep going to material substitution as a solution when material substitution does not mean net zero yet. And a tool, you know, an LCA is very useful for, you know, thinking about tweaks to design, you know, lean design principles or material substitution, but it does not give you the answers in terms of radically rethinking how we're building. And I think that's really important to stress. You know, we need a combination of these approaches, and we can't just rely on new materials that don't exist yet. You know, in terms of, you know, I think the original question was around sort of specific tools. You know, we will, particularly if it's a big project or a kind of portfolio of projects, it is worth looking around. You know, there are tools that are more appropriate for concept stages because they're a bit simpler. If you've got detailed Revit models, there are plugins you can use that will give you spit out a detailed answer. But I think, again, I'd sort of move away from the tool being the answer. The tool is a way to iterate your design. The tool is not going to give you a low embodied carbon building by itself.
I think that's a brilliant response. Thank you, Martha. Dr. Zayed, if I can come to you as well for your thoughts.
I think, I mean, this is a climate emergency, as Martha was saying, and I think just like in society, smaller firms, smaller architecture practices who can't afford the tools, I don't want them to miss out. So I don't think it's right and appropriate where there's clients who want to assess their embodied carbon, they can purchase these off-the-shelf tools, and I think it's very unfair of me to go and recommend that. What I will say to the to answer that question is, first of all, there's a very, well, it's an excellent design guide by LETI, the London Energy Transformation Initiative, and it's a group of very, very dynamic young engineers and architects in London, and they've produced embodied carbon primers. So that should be the first kind of stop to go, and it's a two-pager because people don't like reading things, and it's very visual. It doesn't involve you going through databases of numbers, and this really gives people a benchmark of where to start. And the minute you can start doing that, then you can actually know where you are, what your project requires. Should I be looking at the substructure? Should I be looking at the superstructure? And this is really, really critical. And if you want a free database in terms of your applications, the UK ICE database was funded through UK taxpayers' money through kind of EPSRC funding. So that's a kind of a good starting point. But that's the approach I take. Is there isn't really a one solution that fits the problem. And I think and for anybody starting this, please, a mature student last year, and we sat together and we worked out the embodied carbon of a development. And within 6 months, he became the sustainability champion of the practice, and he was kind of giving advice about what can be done and so on. So it can be a very, very small step that you take, and it can have a dynamic effect across the entire kind of chain of the suppliers, and you know, if it's a small practice, it can help in terms of greater climate education of colleagues and people you work with, and making demands of what should be done and what products should be purchased.
That's brilliant. Thank you. We've had a question in that sort of links to the database that you were mentioning there, Dr. Zayed, which is about does the UK have an EPD database that are measuring the embodied carbon of construction materials or something similar? So I don't.
That's the ICE database is actually based on, the ICE database has a lot of EPDs which are aggregate. Well, they're collected from, could be anywhere around the world, and they are sort of, they would give you a representation of what's low in terms of embodied carbon or not. I do believe the person who's created a circular economy, they've got their own house, which is a zero embodied carbon house, which is on show in Glasgow, next to the main exhibition hall. So I'm sure if you can Google that, you can have a look at that, which relies on modular construction and this kind of cradle to cradle approach, was Neil was mentioning, where we need to think about what happens at the end. Can we actually build in a smarter way where we're not just decommissioning, putting things in landfill? We don't have this huge upfront carbon, but material can be reused again.
That's great. And just on a database, if I can just take a second or so to also tell the attendees that later on this week, I think there will be an announcement from the professional bodies who are all coming together to produce the Built Environment Carbon Database, which can be found becd.co.uk if anybody wants to find out a little bit more about that. But that's designed to be a database at entity level as well as product level, including data like the ICE database, Dr. Zayed, that you were mentioning there, will all be part of that, along with EPDs and other sources. So the Built Environment Carbon Database that will be launched later on this week is hopefully going to be a source that will help us all in terms of getting data for estimating and benchmarking and other things. So that's great. Thank you very much. I'm going to move us on to the next question. I think we've kind of touched on the next question already, as is lowering embodied carbon and the circular economy inextricably linked. I'm going to come over, Martha, to you on that one, if that's okay.
Yeah, absolutely. I was looking the other day, and I think it was, I can't remember how many million tons of carbon have been used in the UK since I was born, but it's a lot of millions of tons of concrete, sorry. And you know, to everything that we've already extracted and used, we should be using to its full extent. We should be putting value on these materials and on these spaces. And you know, as we've talked about before, particularly while we don't have zero carbon material substitutions at the scale that we need, we have to be reusing what we already have. And I think it's a real, it's probably the biggest area that's overlooked in the sector at the moment, in terms of, you know, the physical infrastructure we need to be reusing materials is not there and needs to be created. You know, whether that's proper material processing, but also then ways to connect those processed materials to designers and to contractors to actually use them. I think reuse of existing spaces is another element of the circular economy. You know, how do we reimagine? So certainly for me as a sustainability consultant, how do we make my job about thinking about using spaces creatively, you know, making sure everyone has a home, but using the buildings we already have? That is the circular economy. And that is a, you know, ready-made way to not create carbon that we never think about. And you know, in so many of the talks at COP about embodied carbon, probably will not be mentioned.
Thank you, Martha. Dr. Zayed, if I can come to you on that question as well, please.
Yes, they are very much linked, and I think it's important to think of embodied carbon as part of the whole life cycle of carbon. Is a lot of the, if we don't kind of start doing something now, a lot of the emissions of carbon, based on what Martha said in terms of how many tons there are, a lot of the carbon emissions that were produced in the last 40 years are already in the atmosphere. And all we're doing is, if we're not taking action now, is we're delaying any kind of serious mitigation by 2050 in terms of, if we are reaching these net zero carbon targets. But I will say is it's important to, you know, when we look at embodied carbon and it's linked to the circular economy, there's a lot of money and investment going into digitalization and going into BIM and all these aspects. And I think this should be important to look at how much data can we put into intelligent systems. So it could be assets that already exist in terms of scanning them and looking at their embodied carbon and how much we can save by actually not reusing material in such a way. A lot of these heat loss calculations can easily be done in a kind of a BIM domain, but we're kind of, our main focus is, you know, delivery and getting things done and moving on to the next project. So a bit of a greater engagement, trying to identify what the top are before we get to RIBA, say level 3, in terms of stages, and then we can have much more significant sort of actions, because currently, in terms of looking at the circular economy, waste is, for the construction industry, it's almost a figure. You know, we can't, if we don't start calculating it, at the end of the day, it's just, well, how many skips do I need on site? And most of you've been on a large construction site, it's a cost, it's almost an external cost. Let's just get that stuff paid for and get it off site. So it involves us re-looking at things and reimagining them.
That's brilliant. Thank you. I'm going to move us on to the next question because, as I feared, we're only just over sort of halfway through our questions and getting close to the end of the webinar, unfortunately. So I'm going to move us on. What's the to Neil, if I can pose this question: what's the most efficient ways of increasing the energy efficiency of older building stock while minimising the embodied carbon footprint? If you can try and answer that in a few sentences, that's a challenge in itself.
Well, I think the first step is you're going to make sure the building, as it's currently configured, is operating at its peak efficiency. And operational expertise, the way those buildings are managed is really critical to that. It's about making sure that the building's been perhaps recommissioned, that it's working as it should be, that the equipment and systems have been repaired and are well maintained. Fine-tune the controls. There's lots of digital enhancements that you can start using with control systems now to improve the performance of a building. And what's really important, I think, in a commercial context in the world that I come from, it's about engaging the occupiers and the people in those buildings to work with the buildings as well as they can to reduce their impacts. The next step then is to invest in the building to improve it, and that can be, obviously, its thermal performance, thermal envelope, the passive elements of the structure, replace older and inefficient plant and equipment. Ideal if it's coming to the end of its life, because obviously there's carbon invested in that as well, but you have to do the analysis to see, a point in time where you make those changes, it's going to have a good outcome overall in terms of the new equipment that you're investing in. And add renewable energy sources where you can, put PV on the roof, try and use the technologies that will take you away from the use of fossil fuels. Replacing boiler plant with that relies on natural gas with heat pumps is one option that I know many people are looking at. That can be ground source, water source, air source. There's a lot of research at the moment in the use of hydrogen and using hydrogen boilers. So I think we'll see some of that starting to creep in maybe in the next 10 years, but it's still really in the research stage. But there is money being invested to look at that. So we'd get the benefit anyway of a decarbonised electricity supply going forward, which will help existing buildings the same as it helps new ones in the same way. And therefore, that's probably going to drive us to much more reliance on electrical led solutions in buildings as we move away from fossil fuels. And when you've basically eliminated the impact of your operational carbon, then it all becomes about the embodied carbon. So if you've got an existing building, that carbon's already been spent some time ago. It's about trying to extend its life cycle and maintain it into the future, repurpose it, refurbish it, renew it to get the most from that investment. And the same thinking should go into your new buildings too. Whether that's looking at their life cycle, their adaptability and flexibility for the future, and the ability to deconstruct as well as construct.
Thank you, Neil. That's great. We're unfortunately running out of time, so I'm going to jump us to the last question and open this out to you all, which is, what are some of the best practices or best examples of lowering embodied carbon that you can share? So again, a big question in itself, but if there's any insight, you've already shared a lot of wisdom and insight, but if there's anything else that you can sort of think of that would be valuable to the attendees and listeners to the webinar, that would be great. Martha, I'll come over to you first, if I may.
Yeah, so we've been working on a campaign with the C40 Cities Clean Construction Forum, which is looking at how you prioritise sort of reusing and adapting existing spaces before you get to sort of some of these design and material substitution strategies. And it's been unbelievable, the kind of the examples we've seen around the world, and I really encourage you to check out their work. And I think for me, something that's been really striking is, in a lot of countries where there's a real culture of maintenance and often rebuild after if there's sort of seismic activity in the area, there's every building is subject to retrofit and to repair and is cherished and made to last as long as it can. And I think that's those are the most inspiring embodied carbon reduction examples I've seen, because they mean you don't have to building in its place, they mean that people are living in good quality homes that aren't demolished because it comes to the end of its life too soon. So yeah, Reinventing Cities and the C40 Cities Clean Construction campaign have a whole host of examples that I'd really encourage people to check out.
Thank you, Martha. Dr. Zayed.
I'm just going to sort of give two examples. I think we need some exemplar projects to show that this is possible using low carbon materials. One example I can think of, it was in Vancouver when I visited. It was, I think, a 13 or 15-story building that was purely built out of timber with a kind of concrete core. Now, when you come to approach that, a lot of people say, well, you can't build a big timber, building with glulam and kind of sort of a cassette system, but you can. It's got a concrete core and it's embodied carbon is really low. So I think once people actually see that's possible, whether, as Martha said, it's through a refurbishment or a kind of an upgrade to a part of the city, that's possible. Another scheme which I think I'm developing to use to try and greatly engage people is to, and we're displaying this at COP26, people can't really relate to a kilowatt hour or a kilogram of carbon. It's very hard to, even people in practice. So we're trying to kind of import models, 3D models into a virtual reality domain, similar to a gaming engine, and people can actually navigate a space. And once you click on it in real time, you can get a material substitution. Now, I know there's limitations with technology and so on, but I think that's a really kind of a very good example where people actually, at the time they're purchasing a product, if they can see its rating beyond, say, an EPC, which is a static system, it might allow stakeholders to make different choices and allow them to say, oh, right, I can do that. But alongside that, in terms of approaches, there's a lot of good work being done by ACAN, the Architects Can. It's a kind of a group of young architects who are trying to change the sort of building regulations. There's a scheme called Part Z, which is looking at making building embodied carbon part of building regulations. So they're the other sort of schemes I thought I'll mention.
That's brilliant. Thank you. And Neil, to you, please.
Well, I've already mentioned the Forge project, which is our innovation project. It's a Transforming Construction Challenge project that is supported by UKRI and Innovate UK. So I think that we put a lot of stuff out online. There's lots of articles about the project. So I'd obviously encourage people to look at what we've been doing and the approach using platform design for manufacturing assembly. I think there's also great opportunities from the way that we actually keep the information about buildings better in the future going forward. It will help the circular economy. Simple things like, if we're building in cities, which we're bound to be doing in the future going forward, a lot of energy and time and is sort of wasted trying to create new foundations and digging old foundations out of the ground. If we actually know and have put embedded sensors within the new foundations that we create that will tell us in the future, are they still good to be used again? Is the information there to give reliance for designers to put upon those things to reuse them? And that goes through all the materials in a building. If there is an audit trail back in terms of how they were made, what they contain, what they've done through their life, then people will be much more confident about reusing materials from existing buildings in the future. So I think that there's a big job here for the world of asset management and digital capture of information and data. But ultimately, whether you're extending the life of an existing building or creating a new one, it's got to be a joined up process. It starts with great design, but it's got to involve the construction processes and ultimately the people that will operate and use those buildings, so that we join the whole thing together to get efficient built environment for us. We need built environment. We spend a lot of our life in buildings. We need to provide homes for people. We have to renew infrastructure. But we need to do it in a much more clever way than we have historically going forward. So start with good design through good construction and then operate it properly.
That's brilliant. Look, we're hideously over time, and that's my fault. So my apologies to you all. I just wanted to sort of round up by thanking our panelists. Absolutely fantastic discussion. We didn't even break the surface on some of these topics. I think we could quite easily have spent the full first week of COP26 discussing this. So thank you so much for sharing your insight and wisdom. There's been lots of questions that we haven't been able to address, and lots of questions posted by the attendees today that again we haven't been able to address. So we'll take that back to the World Built Environment Forum team and see if they want to sort of do a follow-up. So my thanks to the panel today. This session has been recorded and will be along with a written summary be available. Please, obviously, everybody feel free to share that with your professional networks. Please also take a few moments to let us know what you thought of today's session by completing the online poll, which will appear on the screens at the end of the webinar. Just a few things to sort of promote before we draw the session to a conclusion. There are a number of other webinars which are coming up, as you can see on your screen at the moment. Please do join us for the next webinar, which is the WBEF COP26 mini-series, which is on Thursday, Inclusivity in Urban Design, Enhancing Livability for All. Please see the website for more details of that. You can also watch any of the previous webinars that you may have missed on the WBEF website as well. My thanks again to A-Site, who are our tech partner, the World Built Environment Forum's lead tech partner, that again, as I said at the beginning, we wouldn't have been able to do this without their support. So thank you, A-Site, for that. I just wanted to promote very quickly the Our Future, Our Planet, which is delivering net zero by 2050, which is it's an essay competition showcasing the best thinking from young RICS professionals. You can find out more about the competition online on the web address that you can see in front of you as we speak. So again, if you can share that and raise awareness of that, that would be great. Moving on to my next advert, Dubai 22. So the World Built Environment Forum Global Summit will be visiting Dubai as part of the Expo 2020 Dubai in January 22. The program will focus on the livable city, agile, healthy and resilient. So again, please visit that website for further details on the program. For the World Built Environment Forum, you can follow us on Twitter, Instagram and LinkedIn, where you can all receive news of upcoming webinars as well as recently published articles. There's also a World Built Environment Forum app from the App Store or Google Play, where you can access the latest innovative global thought leadership content around the built environment. So apologies that we've gone over time today. My thanks again to the panel for sharing their insights. Thank you to the attendees for joining today. And thank you all and see you next time. Bye-bye.